Alright, this problem asks us to find a formula for the area function. So here's our area function. This is the integral. It defines the area. Now this is kind of neat because earlier, 2 weeks ago, we looked at this problem right here. As the integral goes from 0 to b of x squared, we found out that the answer will give us b to the third over 3. And we found that by using Riemann sums and taking those to infinity, and it was really interesting. And so then we used this formula to solve some other functions as we practiced splitting up integrals and such. But pretty much what that formula was that we found was a formula that would give us the interval between, or the area between 0 and b, and b is just a variable that represents any number, so any number. So if that number equaled 3 or 5, and we wanted to find the area of the shaded region, then we would just have to go 5 raised to the third divided by 3, and that would give us our answer. Okay, and so this problem right here is neat because what we're going to do is essentially create these formulas, but you don't have to start from 0. We're going to start from 3, and we're going to do this by using the second part, or they call it part 2 of the fundamental theorem of calculus. So let's write it out right here. We have as the integral from 3 to x t squared dt. Alright, so we have to have a t here because we're plugging in x, and so we can't have it there twice. Alright, so let's see if our formula that we find is actually a little different than this, because instead of our formula going from 0 to any number, it's going from 3 to any number. So our graph would look something like this. We're going from 1, 2, 3 to any number x. So here's my x squared function. Not perfect, I know. So we're going from any number x, from 3 to any number x. Alright, cool. So what's our formula going to look like if we're always starting at 3? Now the 3 is, it doesn't go away. It always has to be 3. So what we're going to do is use fundamental theorem of calculus. We'll take the antiderivative of t raised to the second power, which is t raised to the third power, because we had to add 1 to the 2. Then we have to divide it by that number. That is the antiderivative of that. That should look familiar to us. Then we have a 3 and an x. So now we're going to plug in that x first. We're going to have x to the third divided by 3. And then we're going to subtract, and we're going to plug in that 3. So we get 3 to the third divided by 3. That's 3 to the 1, so this is actually 3 to the second power. Our answer is going to be x to the third divided by 3 minus 9. And so this is our formula to find the area underneath this curve, x squared, or t squared, but your interval always starts at 3.